All right, first thing we've got in 7.1 is almost just really a continuation of chapter 6. The first few problems, though, it's really just fractions and simplifying. So, very first objective here, objective 1, is it's just going to ask you to simplify a ratio. Which again really is just simplifying a fraction. And how it really ties back in with chapter 6 is really you're almost finding the greatest common factor, but instead of factoring it out, you're just going to divide it out and just simplify the fraction. So with 4 and 24, you can divide them both by 4. To get 1 over 6 for the number part. And then with the u's, you can do the same thing with the variables we did before. You can just subtract the powers. So if you subtract 4 and 1, you're going to have 3 left over, and since the bigger power is in the bottom, you basically have to use a third in the bottom. Okay. And just to give you another one of those, just to see what it is that we're looking at for a different example here. Let's go 15y to the 6th over 35 y squared. Okay, with 15 and 35, you can divide both of those by 5. And we make it 3 over 7. And then with the y variable, subtract the 6 and 2 to get 4, and because your bigger exponent's on top, have y to the 4th on top. Okay, so with everything we were doing in chapter 6 with the factoring, kind of ties in nicely with that one. Objective 2, it's the exact same ratio, they just changed up the numbers a little bit. The only difference with the objective number 2 is they add an extra variable. That's all they're going to do. Maybe 24v to the third, w to the third. And that's over 8 v squared w. And again, I would just start off by just dividing out the numbers you can do here. You can divide them both by 8. There'll be a 3 on the top. With the 1 on the bottom, really don't have to have it, because if it's 3 over 1, it's just going to be 3. So for that part, you don't have to put the 1. If you do, that's fine. V to the third and v squared, when you subtract the exponents, that'll leave you with 1v in the numerator. When you subtract the w's, you'll have 2 w's, also in the numerator. And since there really just was the 1 in the bottom, we don't need it. So you can just make it 3v w squared. All right, one more of those. We'll go with 35v to the 5th w squared over 7v to the third w to the third. Okay, 35 and 7, you can divide them both by 7. So that would make it 5 over, and it's 5 over 1, so don't really have to have the 1 there. Start subtracting the exponents, v3 and v5, that'll leave you v squared in the numerator. W squared and w third, you'll have 1w left over, and there's nothing else in the denominator, so that would then wind up being your final answer. Okay, so first two objectives, really it's just greatest common factor. Just instead of rewriting it, you're just canceling it out and dividing the parts. Now, here's the part where they actually go back in and make you do more factoring. Because on objective number 3, they're going to tell you to find excluded values. And sometimes they'll tell you excluded values. Sometimes instead of saying that, they'll tell you it's restrictions. And anytime you're talking about excluded values or restrictions or ever how they want to word this, the big thing on this one is that you cannot have the denominator equal to 0. Because anytime, if you've got a fraction, your denominator equals 0. If you try to divide by 0, that's when you get the error message on your calculator. It doesn't like that. So this one, this is basically, that's the restrictions or excluded values is basically wherever the denominator equals 0. So all you're going to do is if they tell you, all right, tell me what the exclusions are or the restrictions, you just take whatever the denominator is, set it equal to 0, and that's your excluded values. Okay, so the very first problem is we'll have 9x plus 1 over 2x plus 8. All right, and again, all you're going to do is just take whatever the denominator is, and they're going to tell you to list excluded values. You just do 2x plus 8 equals 0. And that's where we're really kind of going back to that one objective that got skipped in chapter 6. Set this equal to 0, and then you're just going to solve that equation. And when you divide by the 2, then x is negative 4. And they should tell you just to list excluded values, so they'll probably give you a box like this, and then you're just going to go back and then just put in whatever numbers you get. And don't know if we'll get to it here first, if it's today or maybe the next class. Sometimes on these you may have two answers because they may have two different values and two different denominators. You know, if you solved another equation and you had x equals 5, then you come back and just say, all right, well, it's negative 4 and 5. But for right now, we just have the one value. So all you're going to do right now is just put this one under this back in the box here. One more of those. Let's go with 3 over 4 minus 2w. Okay, and again, it's just in your denominator. Take whatever you've got in the denominator and make sure that that value equals 0. We're going to exclude that. Okay, so that leaves us with negative 2w equals negative 4. When you go back and divide by the negative 2, w equals 2. Okay, objective 4, same thing on this one. The only difference on objective 4 is now the denominator has a expression, whatever you want to call it, that you're going to have to factor off. So list, find, again, same directions when they tell you this one, whatever it is that you got, you're going to list excluded values. And again, the only thing that's different is your denominator is just a little bit more work that you have to do to it. Yeah. Now, one little thing that they may have snuck in on you here, maybe not, is it's called the fundamental theorem of algebra, which basically is this. If you're solving an equation and you've got something like this, whatever your highest powered term is, That's how many solutions you're going for. You know, before this one, when we were solving this one, it was just w to the first power, so we were looking for one answer. As soon as this goes to w squared, we're looking for two answers. If it was w to the third power, three answers. So that's kind of the thought process sometimes. Now, everything we're going to do, w squared is the highest one we'll go. But later on when you get to pre-cal, sometimes they'll have you start solving different things. And basically, whatever this highest power is that you're solving with, that's how many answers you're looking for. Okay, now here's where, again, it got skipped back in the previous chapter, and we had to go back and pick it back up here. This one, basically, if you go through your factoring rules, this has two terms over on the left-hand side over here. And if it's two terms, there is no greatest common factor, so we don't have that one. But it does have perfect squares. So w squared would be w times w. 1 is basically just 1 times 1. We just need to make one positive and one negative. Okay, so when you get to objective 4, when it says list excluded values, you're going to factor as much as you can, and then you're going to go back and solve it from there, each expression. So you've got w plus 1, w minus 1. We'll set each one of those equal to 0. But again, when you solve it, you're going to get a w equal to negative 1 and w equal to positive 1. And again, what they should do in the homework is this is one where they would basically give you this. Give you the box, and then inside the box you'll go back and put positive 1 and negative 1. Let's do one more of those. We'll go with t minus 6 over t squared minus 49. Okay, and same setup. We're going to take whatever the denominator is, and that's the parts we have to exclude. We're right back to the two terms here again. There is no greatest common factor, but those are perfect squares. So when you factor, one's a t minus 7, and the other one's a t plus 7. And usually by this point, hopefully we go, well, if I'm solving this one, one's going to give me a positive 7, one's going to give me a negative 7, and then I've got my two answers. Okay, so that would be your two excluded values there. Okay, so for those two objectives, especially number 4, that's where you have to go back and work on the factoring. Just whatever the denominator happens to be, factor out as much as you can. If it's 3 terms, you'd go back and do just a regular 3-term trinomial, factor them off. But I think most of the ones we had there were the 2 terms with perfect squares mixed in there. Okay, and objective 5 is really kind of a mix of the first 4 on this one. They're just going to ask you to simplify. And it's going to give you a ratio to work out. So again, we're still talking about a fraction on this one. But this one's almost even easier, it's almost even easier than the first ones we looked at. Okay, so objective 5, they tell you to simplify the ratio, but then they tell you it's already got factored polynomials. And really on this one, if it's all factored, it's really straightforward. Anything that's exactly the same, cancel it out. And all you're going to do is just basically go back in and cancel out anything that's common, identical expressions that are in the numerator and the denominator. Okay. Now, and again, it has to be, you've got 1 in both cases. You can't have 2 in the numerator and 2 in the denominator, or 2 in the numerator or 2 in the denominator and cancel them out. You have to have 1 in the numerator and 1 in the denominator, so that basically on this one, you're just going to go back in and cancel this part out. Because you've got an x minus 7 on top, you've got an x minus 7 on bottom. They'll just cancel each other out. Okay, the 2x plus 5 and 3x plus 5, those won't cancel because this 2 is different than 3. And again, even if they're just that one little bit different, you cannot simplify them. They have to be identical. So those two things will stay. You do have 5 and 45. So this one you can divide them both by 5. Okay, so that'll leave you with 1 on the top and then 2x plus 5. And because you're doing multiplying by 1, you really don't even have to have the 1 there. You take that 1 back out. And you do 45 divided by 5. That'll be a 9, and then you're left with 3x plus 5. Now, and you do not have to do distributive property. Sometimes people will go back and multiply out the 9. No, just if it says it's in factored form, just leave it in factored form, because everything we're doing in chapter 7, just like we're doing in chapter 6, you're going to factor everything out as much as you can. So don't go back and reverse yourself and go back and do the full method. Once we got out of chapter 5, we're pretty much staying in factored form throughout the rest of chapter 7, just to follow through with what we're doing in chapter 6. Okay, let's go with 4, 2v plus 5, and v plus 6. 16, 2v plus 5, and v minus 6. Okay, 4 and 16. Divide them both by 4. And with the rest of the numbers, again, you've got a 2v plus 5 and a 2b plus 5. You can cancel those. And again, because those have the one sign that's different with the v plus 6 and v minus 6, you cannot cancel those because they're just a little bit different. So 4 divided by 4 is 1 on the top, but because we've got the v plus 6 already here, you don't have to put the 1 in. You can leave it off. 16 divided by 4 is 4, and then we've got v minus 6. Okay. Now, and actually, I guess when you enter in, and didn't do it back here either, when you enter this answer in with the parentheses, if there's nothing else, there's no distributive property on those, you really don't have to have those parentheses there. Same thing with this one. You don't have to have the parentheses on the top part because there's nothing else there, so you really don't have to do that. If you put it in, you're still okay. If you want to do that just to be on the safe side, that's fine. But if there's not a number to multiply into this part, you don't have to put the parentheses around it. Okay, objective 6, same thing. They just give you a little different variety of the fractions. But now, instead of them all being to the first power, they just bump up the powers a little bit. Okay, 15 and 20. You can divide both of those by 5. So that would be 3 over 4. And with everything else, you're just, again, canceling out the different parts. With the y minus 6, with this one you have 1 that's here. So if you cancel 1 out of the top, take 1 out of the bottom, you're still going to be left with 3. Y minus 6 is in the bottom, because again, you're just subtracting the exponents. Same thing with the 3y plus 7. You've got 1 here and 5 here. So if you do 5 minus 1, that's 4. And you'll have 3y plus 7 to the 4th power left in the numerator. Okay, I'll give you one more of those. We'll go with 20y squared, y plus 8, 3y minus 5, over 12y to the 5th, and then y plus 8 to the 4th. Okay, 20 and 12. You can divide both of those by 4. So dividing by 4, that's going to leave you 5 over 3. And now the y's have their own thing we're doing here. So you've got y squared over y to the 5th. Subtract those two and leave you 3. And because the bigger power is on the bottom, you would have a y to the 3rd on the bottom. With the y plus 8, again, technically that one is to the 1st power. So taking 1 off the top and 1 off the bottom, that'll leave us with y plus 8 to the 3rd on the bottom. And there's no other 3y minus 5, so it stays right where it is. Okay, so that one's just taking the first two objectives where you had to cancel things out. It's still doing that exact same thing. They just now, instead of having it just be y to the 1st and x to the 5th, now it's just an expression, but you're still going to just go back and cancel out the different parts here. All right, and objective 7, back to factoring again. So they kind of keep bouncing back and forth on all the factoring we're doing here. This one, it is going to tell you that when we're factoring on this one, that you're going to simplify using the GCF. So it is factoring, but all we're going to do is just take out the greatest common factor for this. So 16x plus 40 for the numerator, and then 10x plus 25 for the denominator. Okay, numerator, 1640. Just go through the numbers. It's even, so we know we can do 2, you can do 4, but 8 is the biggest factor you can take out. So that would leave you with 2x plus 5. Denominator, 10 and 25, that's 5. So that would also leave you with a 2x plus 5. Now, once you take out the greatest common factors, it's kind of hit and miss as to what you can cancel. 8 over 5, there's nothing you can do to simplify that one, but you can get rid of the 2x plus 5 in both parts. So for that one, the final answer would be just an 8 over 5. And sometimes it'll be that you can simplify the number and these two expressions won't simplify. So it's just kind of, hit and miss is exactly what you're going to be able to cancel out when you go through each part here. Same problem, a little different look to it. On the top with the numerator, 7w plus 21, you can divide them both by 7. And that would leave you with a w plus 3. On the bottom, you've got 3 and 9, so you can divide them both by 3. You had w squared and w to the first, so we can take out 1w. That leaves us with a 3w. Oh, sorry, hang on. I'll leave you with a w plus 3. All right, and same thing again. You've got the w plus 3s are the same. Those will cancel. Nothing you can do with a 7/3, so it's just going to stay. That will be your final answer. All right, one more of those, just to make sure we got everything going here. So 8x squared minus 20x, or 4x squared minus 28x. Okay, 8 and 28. 4. I mean, 2 would go, but 4 goes in both. 8 won't go into 20, so 4 is the max we can do on the top part. You do have x squared and x, so you can take out an x. Dividing it by 4, you're going to be left with a 2 and an x on the first one, and then 20 divided by 4 would be 5. All right, denominator. 4x and 28x, that's also a 4x. Taking out one of the x's, we've got 1x left over. 28 divided by 4 is 7. So on the outside, you can get rid of the 4x and the 4x both at the same time. So that would leave you with a 2x minus 5 and an x minus 7. And again, really, it's just an extension of factoring. You're just factoring the top part, factor the bottom part, and then anything that you have that you can simplify from there, then you just go back and simplify. Okay, and then objective 8, it gives you a little bit of a different, it's simplified, but then they tack on at the end that with this simplifying, you're going to be using 1, negative 1, or not possible. And the first one really is kind of the main one to hit on. This is really the big thing they want to get out of objective 8 on this part. If you get ready to start factoring and doing all the cancellations that we're going to do, if you get to a point where you get to a problem and you're like, okay, I've got 4 and 3x. This one I've got 3x and 4. The numbers are all correct, but the signs are backwards. Basically, it'd be like when you're doing factor by grouping and the number, the parentheses were close, but they didn't quite match up. That if you get the correct numbers, but the signs are wrong, then basically you can take one of these expressions and divide out a negative 1. And it doesn't matter whether you do it from the top or the bottom. So for this one, what we're going to do is we're going to say, all right, well, since we've got the correct numbers, but they're in the wrong order, let's just take a negative 1 out of this thing and see what happens. So taking 4 divided by -1, that'll make that a -4. Take the -3 and divide it by -1, that'll make it a plus 3x. Which, when you turn it around, put the 3x first, now you do get the 3x minus 4. Okay, so if the numbers are correct but the signs are in the wrong order, just factor out a -1 and that'll basically change everything around so that then you can go back and cancel this and this, and you're left with -1 in the top and nothing in the bottom, so that would just come out to be that answer would just be a -1. Okay, for the second example that they would throw at you. Same directions, going through the same process on this one. But everything is positive. Where if you've got 6x plus 5 and 5x plus 6, the numbers are reversed. This one, is always 3x and 3x. This was 4 and 4. If they do it like this, where the numbers are, you've got 6x and 5x, this is one where they would say, all right, this is not possible. That I think when you're going through these problems with this objective, they give you 3 options out to the side that they're going to give you 1, -1, and then not possible, and you just got to go back and click on which button it would be if you simplified this problem. So I think everything in this objective, it's going to give you those 3 options. It's going to give you a little box, and you're just going to pick which one you think it is. Just click on the dot and go from there. Okay. For this one, let's go v plus 6 and then -v minus 6. Top part's good, nothing you can do there, but since both of the numbers are negative on the bottom, divide out the -1 to leave v plus 6. And from there, of course, then you can cancel. So it leaves you basically with 1 over -1, because anytime you cancel, you're going back and putting a 1 in there, almost like a placeholder. And again, if you've got 1 over -1, that would just be -1. Okay, and then they'll throw one at you just to make sure you're not getting too far ahead of yourself on these. Just to make sure you're paying attention. They give you one that's like this, where you got v minus 7 and -7 plus v. It looks like it's a -1, but if you look at the numbers, they're both negative here, they're both positive here, that all they've really done is just rearrange this thing. So if you go back and rewrite it so it's v minus 7 here, it's the same thing as here. So they cancel. But one's in its place, that answer would just wind up being 1. So they try to trick you. But again, if you just check that one real quick, both of the 7s are negative, both of these are positive, so all they did was just rearrange these 2 terms. If you just go back and rewrite so the v is first, then you can see that it's the same thing and you can't pull those out. Okay, and then the last 2 objectives. This one is just basically straight up factoring. You're going to simplify by factoring. And basically you're going to do this. You're going to factor the numerator, factor the denominator, and then cancel like terms, if you want to say it that way. we'll say not really terms, more expressions. Okay. Now, adjective 10 is going to be the same thing. It's still going to be simplified by factoring. They're just going to bump up the amount of factoring that you may have to do. So the last two things, it's still just basically you're going to factor, and then after you factored everything you can, you just go back and cancel out anything that you can. Okay. And really the biggest difference between objective 9 and 10, objective 9, you're really just going to have to factor one part, either numerator or denominator. Objective 10, you're going to have to factor both parts, but still can't, same concept when you go through these. Okay, denominator, u plus 2. There's nothing you can do with it. On the top part, though, we're going to find the factors of 4 that equal 4. Well, it's not going to be 1 and 4, because that would be 5. So for this one, you'd have to factor this one off and make it u plus 2. And u plus 2. Then you can cancel one of these with one of them on the bottom. So that'll leave you with the u plus 2 on the top. And again, basically put the ones there. So if it's over 1, we don't have to put it over 1. We can just leave it as u plus 2. Okay, one more out of objective 9, and we'll get one or two examples out of objective 10, and that'll wrap us up. Okay, again, denominator, nothing you can do there. And you can pretty much kind of, on these, you can basically take a hint that, okay, if I've got y plus 6 in the bottom, I'm pretty much going to have y plus 6 in the top. So if you go with the factors of 42, well, they're kind of giving you a hint, you're going to have to use 6, because it's in the bottom. If it's not, you're not canceling anything. So factors of 42, that's 6 times what? That'd have to be 6 times 7. And 6 plus 7 is 13. So that would be y plus 6 and y plus 7. Again, go back and cancel out the y plus 6's. And that'll leave you with a y plus 7 in the numerator. Okay, and again, because that's over 1, you don't have to put the 1 on the bottom. Okay, so if where they've got the denominator or numerator already with just one term, one expression, that's kind of giving you a hint is what you're going to have to factor out. Because if not, you're not going to cancel anything, which defeats the whole purpose of simplifying. So they're kind of giving you a little cheat ahead on this one that you know that you're going to have to find a y plus 6, which makes the factors go that much faster. Okay, and objective 10, exact same problem, exact same setup. It's just now you're going to have to factor the numerator and factor the denominator and then just go back and cancel. Okay, in the numerator, you've got 2x squared minus 98. There's two terms. So first thing you're always looking for is the greatest common factor. 2 and 98, you can divide them both by 2. So that'll leave you with 2, and then x squared minus 49. Okay, once you do that, what's left over in the parentheses, that's 2 perfect squares. So you can take the x squared minus 49 and make it x plus 7 and x minus 7. Okay, bottom part is just 3 terms. First term is 1, so this one we get to jump straight into it. You're looking for the factors of -7, which again, there's only one way it can be. It's got to be 1 times 7. It's just a matter of getting the signs correct. To get it to be -6, the 7 is going to have to be negative, and then the 1 would have to be positive. Okay, so we need an x plus 1 and an x minus 7. So you can cancel out the x minus 7's. You get 2 times x plus 7 in the numerator and x plus 1 in the denominator. And again, with that denominator, there's not anything else around the x plus 1, so you don't have to put the parentheses there. Okay, one more of those and we'll be the last one we'll do though. Okay, numerator-wise, we're looking for the factors of 40 that would get us 13. Okay, if you go back through and check your list on 40, it's not going to be 1 times 40. It's not going to be 2 times 20. 4 times 10 gets us a little bit closer, but again, since they're all positive, we need the sum to be 13. Finally, we get 5 times 8 to work for that one. Okay, so in the numerator, breaking down to 40, the pair that's going to get us to add up 13 would be the 8 and 5. Okay, bottom part. Here's where, again, you want to kind of go through those, because you could start off just by doing 4 times 20 and doing the AC method. But on the bottom, you do have 3 terms. The first term is 4. You always look for a greatest common factor. 4, 24, and 20, you can divide all those by 4. So before you do all the AC method, go ahead and take the 4 out first. I'll leave with v squared plus 6v plus 5. Okay, so for this one, again, if you start factoring this off, the factors of 5, well, there's only one factor of 5. It's got to be 1 times 5, right? Because that's the only way you can get, that's the only factors of 5. So it's going to be v plus 1 and v plus 5. Okay, so then we've got v plus 5 top and bottom. Go back and cancel those out. And whatever you've got left over, that is going to be the answer that we're looking for.